questions for anyone down this end? Questions?
Everyone is just kind of looking at that.
It's kind of cool, isn't it? Right?
Coolest thing.
It's cool. And again, the smart board lets them, they can move them. And also when you do ones that aren't factorable, you can't make a rectangle. So you can't solve it. So it's an interesting sort of self-checking exercise.
Wouldn't
that have been a
it's
great way to
the
learn
new
it?
SAT problem, just so you know.
Wouldn't that be a great way to learn it?
I get the X's, but what are the dots?
They're the units. So like back when they were doing multiplication arrays, they were literally just laying out numbers. The numbers represent, counting numbers. So when we get here, we're looking at the edges. We're counting the edges. This is 1, 2. When I count this edge, it's actually an X. When I count this edge, it's an X. But when I count this edge, it's a dot. So I start to count them 1, 2. Just like when they laid out the V bars.
Because if you take the B bar and look at it and see.
Yeah, if you
You're
take,
looking like you're looking
You're
down
looking
on
at
it.
the end of it.
Right,
Okay.
because for an array, you're looking at the end points. So for here, you're looking at the end points. This end point's a rod, that's an X. This end point's a dot, so it's a unit.
Okay.
so if you hold up one of those,
Right,
yeah,
you're like looking at the edge.
you're looking at the edge.
And so that edge
Yeah.
matches this. And this edge matches this. Any other questions?
Is that correct?
What?
Is that correct? Yeah, plus 2, isn't it?
6x squared.
6x squared. So you guys probably learned the FOIL that this.
Yep.
This is 6x
First dollar,
squared.
minute last.
3x,
Yeah.
4x would give me 7x.
Yeah,
And 1 times 2 would give me 2.
there's a 1 I saw 3.
Yeah, it's on the
Yeah.
other.
On the bottom.
Right.
It's correct.
Right. So the
It's
FOIL.
On your table, you're showing.
Lisa is
The
definitely
one that's in
hoping
your
that it is
hand.
correct.
She's looking at the one in your hand.
It's in your hand.
So this was 2x plus 7x plus 6.
So that's why it's not the same.
Oh, it's a different problem. Yeah, those are 2 different problems.
Yeah.
I'm sorry, in case you need a different example. So right, so this one is totally different. The trinomial is different. It had different numbers or different parts. They would assemble it into a rectangle, and then the same thing. The factors are the sides.
And our kids in upper do this a lot before they get to Lisa, using the actually using the golden
beads, right?
Yeah.
And how do they
So I don't have to get these because they can visualize them when I put them on the board.
And how do they learn to do it without visualizing? So just like we did.
Yeah, how
Well,
did we do that?
because once we've talked about why it works, then we talk about the algorithm of the FOIL method. And here's how you can keep it straight in your brain.
Easier
Yes.
for them to follow.
Yeah, right. So this is more of an explanation of why. I'm a big believer in math should make sense. So once you've seen this, then we're going to go with the algorithm of how to get to the answer.
But it's a natural kind of progression. It's the same way, when they come to us still using the stamp game for certain operations. They very quickly get tired of using the stamp game and want to be able to do it in their heads. So with some kids, they figure it out what they're doing and, kind of have a picture in their mind of what they're doing, and they quickly move away from the stamp game. Others, we may have to sit together and talk about, well, what is it that we're doing here with this stamp game, and kind of talk through it. And, I'll often say, can you get a picture in your mind of those 7 tens that you laid out? And we're going to take 5 away from those. How many are we going to have left? And you actually see kids close their eyes and go, okay, I have 7 and I'll have 2 left. And yes,
Yeah, and then
because
they'll
getting that
actually
picture.
draw out the stamp game, which
Yeah,
is
some of
really,
them
really
will.
fun, because
Yeah.
they don't want to actually get out the stamp, which I don't know if you guys know, everyone knows what a stamp game is. I could go get one, I guess.
Sorry, I should.
We have one.
Lover, since you're closest. So they'll actually draw the little pieces of the stamp game as if they were laying it out on the rug, but they'll have it on paper. So that it's interesting to see them sort of, but they have seen it for many, many years. So, they are getting to the point where.
Because I have 2 students that are using the stamp game now, so.
So it begins all the way with us.
Yeah,
and
when
they
the
continue
stamp
to
game
use
comes
it
in, we'll explain to you
throughout.
what exactly that is, but.
I do think students that come all the way through the program, though,
Really?
have a really good concept of numbers.
Yeah.
And so they can visualize it very easily. So you, at my level, you can move pretty quickly pass the pictorial to the algorithm because they can kind of see it in their head. Though they think this is cool, and I think this is cool, so I've been doing it
And then
for
new
a
students,
decade.
you know, that haven't had this experience, love the materials because they've never seen them before. So, you know, it's an interesting mix. But so this is the stamp game.
Yeah, that's the bead bars. I mean, the golden beads, and then they move to this. It's the next layer of
Do you want
abstraction.
me to do that? Okay.
Yeah.
So instead of having that one golden bead, this is what they now see as
That's
a
the
unit.
unit.
Instead of having that 10 bar, they now see the 10 square stamp. And then the 100 would represent the 100 square, and then the 1,000 would represent the 1,000. So you're going from, you know, things that are getting, you know, from a small to a larger amount. Here, these are all the same size. So they need to sort of go from that to that abstraction.
Those are very concrete, so they can hold the units in the hand and see a unit. When they hold the 10 rods in their hand, there are 10 units attached to the rod, so they can physically count it.
And then these are color coded, so they've always used green as units, 10s as blue, 100s as red, and then this is the units of thousands, so it's green again. And so this will continue. So 10,000 would be blue. 100,000 would be red. And the way that you would use this material, we use this for addition, subtraction, multiplication. I mean, it's used for division. It's used for all operations, but I don't know if you guys want me to do a problem or not. But.
Oh, yeah, that's right. Yay.
So that was
Such a good doobie.
Just cover up.
Put on the chair.
Put it right.
So anyway,
Where is that million cube?
In the library.
Oh, it's in the back in the library.
So we actually have a
Million cube. That it's just the coolest thing for the kids to see. And, you know, so they build up to this million cube, and then you say, so what would come next? And they'd say 10 million. And then we talk about what that might look like. You want to build it? And some of them are like, yeah, let's go build it. So it's a lot of fun. It's really cool.
So this is why you see so many children walking around our classroom, because they go and get things from all the different rooms up the building. So do you guys have any questions on anything that you've seen or heard or?
Is there homework for that at that level?
In math?
I wouldn't know how to help.
Yes, there is, if they don't finish their classwork, they're going to finish it at home, but it wouldn't be pictorial. That would be part of the lesson, and then we would talk about what the algorithm is to get to the answer.
Where do you want it?
Over there.
I would think that you
10,000,
probably know the
100,000
full methods.
million.
When they came home and they knew this part, you would be able to fill in the algorithm because you know that part. So you would be able to make that connection.
Still have the pieces
Yeah,
on
absolutely. Because we're looking
desk
for,
in my room.
once they understand the concept, then once you can visualize what you're doing, then the algorithm is fine to get to the answer. You just want to make sure that you know why you're doing something.
It's a little trickier with the stamp game, and when you guys teach them, you just cross that off and you need to take one away, because that's really not how we do it. But, you know, you guys can cut up your own little colors at home and,
The thing that makes such a difference is when I actually taught high school, well, junior high math. And so you teach division and you teach a gazinta when you do division. 8 gazinta, 6 gazinta, 8, one time with 2 left over. Nobody knows what a gazinta is. The kids just memorize it as the teacher said to do it that way, and you try to figure out, 6 into 42 is how many times, fingers and toes. What they do with the stamp game is it's actually laid out so that you have 6 skittles, lovingly referred to, 6 skittles across, and you're going to divide and put the stamps in front. And again, it creates that array. you'll see how many times does it go in. It goes in 600s, there's 100 under each, there's 2 10s under each, there's 3 units under each, and there's 1 left over. And they do that repeatedly, repeatedly, repeatedly. And then they learn how to record everything, and everything that's on the rug actually fits into the division algorithm that you and I know. Put it down, subtract, bring down, subtract, cross out, all that stuff. But it actually has a physical representation, which is the coolest thing, because Sophie's actually doing this. She's trying to figure out how to get it in her, how to do it in her head. Because she knows you can do it in your head, but it doesn't quite, and it happens, and she, the students have done enough that have taken them from primary beginnings to primary to lower, that they see that they eventually can do it in their head. They know there's a way that you can do it in your head, and that's kind of like the holy grail of math. I want to be able to do it in my head abstractly, and they work so hard to try to do that. But it eventually clicks where what they were saying, they can close their eyes and they can see, oh, that's how that makes sense. But it's a matter of physically touching and moving them over and over again until it's not just muscle memory, but the abstraction makes sense. So it isn't just because Miss Quinn said so. No, that's good enough.
Oh, that's usually what they tell us, though. Yeah.
It's the best reason. It's the best reason. Miss Quinn told me to do it that way.
Right.
But the math material makes teaching it and hopefully learning it so much more simpler, so much more easy for them.
Do you get feedback from high school? They say these kids really know.
Academically, the kids go on and do very well, yes. I think that, and in middle school, we have 16 students. Ms. Davis is my partner in there. There are 5 math groups. Our biggest math group is 5 students. Most of our math groups are 2 or 3 students. So getting a lot of one-on-one attention. Someone's checking to make sure you're getting it. I'm looking over your practice problems. They have an assessment every couple of weeks. They have to have an 80% mastery to move on. So you're getting a lot of individualized attention. So hopefully.
Well, I have a story. I mean, my girls, and I have 2 sons that went through the program here, but my girls went to high school locally here in Westminster. Their math teacher actually wanted to know where they had studied because he was just sort of blown away by what they knew. Just sort of abstractly, without really, and
I do think the number sense that students have from going all the way through the program, the number sense students have is really makes math. I love math, so I like teaching it no matter what, but it really makes it fun because they have good number sense. And that's a hard thing to come by.
Well, we're not teaching to a curriculum. We don't have to move on. If they're not ready to move on, they're not moving on. They're going to stay learning what a 100 means. What's 100 square mean. We're not pushing them forward. It's about the child. So when they get it, they get it.
That's good.
And what are we looking at here again?
Oh, so we would again begin with a unit, and I think it's about the size of that 1 centimeter cube on top of the pink tower, right? And then we'd have, you'd put 10 of those together and you'd have a 10 bar, okay, a 10 rod. And so it's the form of a rectangle. And then you put 10 of those together and you have a little 100 square. And you put 10 of those together, 10 of those 100 squares together, and you have 1,000 cube. So it's, what fraction of that? Fraction of whatever fraction of a million. Come on, somebody. It's 1,000 times 1,000 times 1,000 makes a million. So 1,000th of that, and then you put 10 of those together and you get that blue 10,000 rod right there, that
You'll note
rectangle.
that the green lines, there's like green fine
Yeah.
lines, and that shows how large a thousands cube would fit beside it with the
Right.
material.
So each of these is 1,000. I think I know they're in our room. So each of these is 1,000. And then you put 10 of these together and you get 100,000. Okay, so between those lines. And then you put 10 of these together, stack them up, and you get this million cube here. So it's a really good visual for the students, and it's a lot of fun to kind of see.
And they want to know if actually 1 million of those fit in there. And I said, well, if you would like to try that, then
The one thing with this too, with the students, if you look, the squares on the floor are essentially a foot, give or take. So we put this million cube against a corner and we figure how many across, how many down, and that big numbers fascinate kids at this age. That's like 100 million, bazillion, Google quintillion. They also like quintillion, figuring it's my favorite number. But we figure out how many of these could we put in one layer, how many million cubes could we put. Then we try to figure out, if you stack them on top, how high would it go? So then we try to figure out how many million cubes would fit in the classroom. Or then we imagine if that's how many in our
so
classroom.
that's what they did down there.
And how many classrooms are there? So it's just kind of that whole idea of, big numbers and wrapping your head around that. And it helps when you look at science stuff, science stuff, and you just take a look at either extremely large numbers in space exploration, conversations in astronomy.
Which we looked at, and we really broke it down, and we scaled it down. That even if the sun is the size of an 8-inch sphere, how far are they away? And we paced it off, how far that is. So then they really start making sense of these astronomical distances.
So it is what Lisa said. They have a sense of what numbers are, not just squiggles on paper and worksheets and, even answers or odd answers in the back of the book, kind of.
Well, and I also think that, as primary parents, when you see the same thing coming home week after week, bring me, you'll see that over and over, or a math edition with the static edition with the golden beads. It's repetition. It's all about repetition. It's constant, doing it over and over and over. So then when they get to lower, then they have a better idea, and then they do it over and over there, and then they move on. And by the time they get to Elise, they've got it, because they've done the repetition. Montessori is all about doing it over and over again.
We also make them make a lot of corrections. And so, the feedback that I sometimes get from high school is, oh, they don't make me correct my stuff. Yay, and I'm thinking, no, because that's where a lot of the learning takes place. So we do, we ask them to make a lot of corrections. We want to make sure, we want to figure out where the mistake is and help them not make it again and again and again.
And that it's okay to make a mistake and then, move on from there. So.
Yeah, so you'll just kind of start doing this.